astronomers have discovered a mysterious bubble in the constellation Cygnus, which is keeping experts on the edge of their seats with powerful gamma-ray bursts. In contrast to the terrestrial CERN, however, this cosmic particle accelerator is also overshadowed by huge question marks, because we have no idea what kind of object we are dealing with here. The only thing that is certain is that the hidden structure produces gamma-ray photons in the order of a quadrillion electron volts, and that this makes it one of the most powerful gamma-ray sources in the entire Milky Way. If you like, the foundation for today's video was laid over 100 years ago, on August 7, 1912, to be precise. After all, this was the day on which the Austrian physicist and enthusiastic balloonist Victor Franz Hess once again ascended to dizzying heights to investigate a particular phenomenon. Hess knew that the air on Earth is not completely electrically neutral, but is partially ionized. In principle, scientists at that time assumed that the missing electrons were due to radioactivity in the Earth. But if this is true, as Hess thought at the time, then the air ionization should steadily decrease with increasing altitude. After the Austrian had ascended to 4,000 meters aboard his hot air balloon, he made an astonishing discovery. There, a special electromagnetic radiation known as gamma radiation was half as strong at such high altitudes as it was on the ground. At 5,000 meters above the Earth's surface, the intensity of the gamma radiation had actually doubled, and Hess immediately realized that terrestrial radioactivity could not be the source of the gamma radiation. Instead, his revolutionary approach stated that we are dealing here with radiation that comes directly from the universe. But in the end, it would take another 25 years and countless debates with his colleagues before the Austrian physicist was awarded the Nobel Prize for his discovery of cosmic radiation. And even though the general term cosmic radiation has been retained to this day, strictly speaking, cosmic gamma radiation is not actually included. But what are gamma rays anyway? And what are their sources? Well, in this case too, the historical research roots lie in the early 20th century. In 1902, the British physicist Ernest Rutherford had discovered that atomic nuclei emit three types of radiation when they undergo radioactive decay. He named the corresponding types of radiation after the first three letters of the Greek alphabet: alpha, beta, and gamma. While the first two are particle beams, the third represents high-energy electromagnetic radiation. If we then move away from the terrestrial research sites of the turn of the century and into the depths of space, we see that unlike particle radiation, cosmic radiation radiates almost in a straight line from its point of origin, thus laying a galactic track for experts that, in the best case, lead straight back to its source. Gamma radiation usually arises as bremsstrahlung or synchrotron radiation when high-energy particles are accelerated or decelerated. The main sources of these high-energy particles are cosmic rays, supernovae, black holes, binary star systems, and pulsars. However, things get a little trickier when the gamma-ray source of your desire is literally hidden, and then also attracts attention with extreme outbursts that defy every known pattern. The invisible particle slingshot. Where do the extreme radiation bursts come from? Basically, the Earth is incessantly bombarded by the particles of cosmic radiation, the largest and also lowest energy part of which comes from the Sun, neighboring stars, supernovae, and the center of the Milky Way. But as already mentioned, there is also gamma radiation, and indeed gamma-ray photons with an enormous energy of several peta-electron volts can rain down on our blue home planet. Just to be clear, we are talking here about an order of magnitude that exceeds the energy of a particle in the Large Hadron Collider at CERN by 1,000 or even 1,000,000 times. The fact that the elemental gamma forces of the cosmos are not to be trifled with is demonstrated by the following. A research group at Ohio State University addressed the question of what would actually happen if the Earth were to be directly hit by a gamma-ray burst occurring nearby. At the end of the study was the not exactly rosy conclusion that such an event could cause nothing less than mass extinction on the entire planet. In fact, the ozone layer would be so severely affected that the global food supply would collapse, and the climate and atmosphere would undergo equally long-lasting and dramatic changes. Well, at least that is the ugly theory. In research practice, however, the experts are primarily concerned with the question of where the exceptionally energy-rich gamma-ray photons come from in the first place. In fact, this has only been partially explained so far. On the one hand, it's conceivable that the roots of some of these extreme particles lie outside the Milky Way, and on the other hand, that some of them originate from certain zones of our home galaxy, such as the star nursery Cygnus X, which is 4,600 light-years away, located in the constellation Cygnus. This structure consists of hundreds of hot, massive young stars and several densely populated star clusters, and it also held a spectacular discovery in store for the experts. Specifically, a research team using the Large High-Altitude Air Shower Observatory in China has discovered that at the heart of Cygnus X lies a vast area characterized by intense, high-energy gamma-ray bursts. In total, the experts identified around 3,200 gamma photons with energies of over 400 tera-electron volts, as well as 8 events with energies of more than 1 peta-electron volt. To put that in context, that's over a quadrillion electron volts. The fact that such a discovery was made within our Milky Way was surprising, to say the least, for scientists. After all, they had previously assumed that cosmic rays of such high energy were more likely to come from extragalactic sources. In the same breath, however, the new finding immediately led to another question. What is the background of this cosmic particle accelerator? A hidden record holder. In view of the data obtained, it's clear that there must be something in Cygnus X that accelerates atomic particles almost to the speed of light. Once the particles have received their speed boost, they collide with the dense gas around them, ultimately releasing energy in the form of gamma radiation. In this regard, the researchers state that the detected values can only be explained by the fact that the original particles were accelerated to energies of at least 20 peta-electron volts, and that they thus significantly outshine the average observations in the Milky Way. In other words, there are also sources and processes in our galactic home that can produce cosmic radiation at such high energies. But which ones? Well, that is precisely the question. To get one step closer to the long-for answer, the scientists first analyzed the intensity distribution of the emitted gamma radiation. Consequently, they came to the conclusion that the high-energy protons originate from a point source in the center of the Cygnus bubble, and thus from an area that also contains the massive star cluster Cygnus OB2. The stellar colossi that call this place home are among the most massive stars known, and some of them are 100 million times more luminous than the Sun. It's possible that this is precisely where the gamma-ray secret lies. Astronomers believe that the immense luminosity and the associated strong stellar wind transform the young stellar giants of Cygnus OB2 into genuine particle accelerators. After all, we're talking about stellar winds that reach speeds of 3,000 kilometers per second. In combination with the location, age, and enormous energy values, experts recognize this as the most promising candidate for the cosmic gamma-ray factory. At this point, however, it should be noted that although this is a plausible theory, at the end of the day, it is only a theory. As things stand, we simply do not know which unknown structure is really responsible for the extraordinary observation. This is something that future research will have to clarify. What we do know, however, is that this was by no means the first extreme gamma event to fascinate researchers, and that the other entries on the list also hold many mysteries. When the strongest gamma-ray burst of all time hit Earth, in the end, the past always catches up with us. And in the case of the universe, this is meant quite literally. A cataclysmic event occurred in a distant galaxy 1.9 billion years ago, and its gamma-ray burst hit Earth on October 9, 2022. Shortly after, the two space telescopes Fermi and Swift automatically sounded the alarm. It was clear that this was the strongest and brightest gamma-ray burst ever recorded. But wait, there was something else. Hadn't the researchers determined that the impact of a gamma-ray burst would wreak havoc on Earth? Well, yes. However, this only applies to the event occurring within 500 light-years of Earth. According to the study results, at a distance of more than 3,000 light-years, such an event would no longer pose any danger to our earthly home. And yet, follow-up investigations have shown that the record-breaking eruption, despite its distance of almost 2 billion light-years, also left its mark on our planet. Named GRB 221009A, the event still caused a measurable change in the Earth's ionosphere. The bottom line was that the outbreak was just as intense as it was mysterious. After all, what explosion so far away could have been so powerful that it even made the night sky flare up? In fact, the flash lasted an impressive 13 minutes, and the afterglow of the spectacle is still visible today. The eruption exceeded the energy of all previously measured gamma-ray bursts by a factor of 70. It's therefore not surprising that the phenomenon became known as BOAT, short for brightest of all time. What is more surprising, however, is the cause that the experts have now finally uncovered for the mega explosion. Surprisingly, the investigations with Webb's NIR-SPEC near-infrared spectrometer have shown that the record outbreak was actually caused by a supernova. Characteristic element signatures, such as calcium and oxygen, were detected in the corresponding spectrum. But to the astonishment of the astronomers, the supernova was neither particularly strong nor exceptionally bright. In reality, it hardly differed from the explosive deaths of stars that are accompanied by much less energetic gamma-ray bursts. But why on earth was the radiation so extreme in this case? Well, the researchers have yet to provide a clear answer to this question, but they suspect that it may have something to do with the star's specially bundled particle jets. These are created when rapidly rotating massive stars collapse, and they can then race through space at almost the speed of light. If these jets are particularly narrow and concentrated, they form a very bright, energy-rich beam. And lo and behold, the record flash did indeed embody one of the narrowest jets ever observed in such an event. So, has this solved the astronomical case? Well, not quite. Because at the same time, the experts admit that this is only a theoretical approach, and that other factors could well have been in play at the time. So, it's still not known when the mystery surrounding the violent eruption will finally be solved. Researchers estimate that they will have to work on this question for several more years. The only thing you'll be nibbling on are, hopefully, only your snacks when you watch our next video. So now feel free to hit the thumbs up and subscribe so you never miss a new video from us again. We'll see you soon.